Yeah, that looks good.
You need to move in a bit. Hey, folks, we're just organizing ourselves here. Greg, come in a bit. Right.
There we go. That's good.
There we go. Now, let's close that. Okay, let's see if we have everything going as it should. Let me know if we have sound. Still don't know what this red hand is for. I know what the black hand is for. Right, the black spot. Anybody know what that was in a famous book, The Dreaded Black Spot? Do you know, Greg? I bet you do. You just can't think of it. You read this book when you were a kid. And you probably saw the movie. Anyway, we have, it's around the wrong way. We have 21 people watching at the moment, which is good. So I guess we are okay. I'm going to delay the first subject, which was the review of the rules for the cylinder head porting shootout, because I'm going to make a bet that there's only a couple of guys that are in the members only that are watching, and I need them mostly all to be watching, although I'll send out an email with the full details. But anyway, quick rundown on the rules. Oh, and before I get to that, let's talk about what was I going to talk about here? Supercharged engines and non-supercharged engines, right? We've got this option of whether we have let's say we're looking for 500 horsepower. No, let's make it 1,000. Is it more effective to have a turbo boosting a smaller engine, or have a big engine to start with, right? And I'm going to pose that question. How many of you would go for a big cubic inch engine? Let's say you can have either a 2.5 liter turbo motor boosted at 20 pounds above atmospheric, or you can have a 454 big block, normally aspirated. Which one would you go for? Charles from Pahrump. I wonder where that is. Hi, Stepside. Right. Did you get the rules I sent out, and do you have any questions on them? That's Mr. Stepside. Now let's ask that question then. Which would you go for? The turbo one or the big one? Think about it. Bill from Dallas, North Carolina. Oh, you're only just up the road. Yes. You could drop by sometime. Not getting any answers to this. Well, I want you to consider something. I'm thinking there's diminishing return with more boost and here, but I guess we need to know what kind of supercharger. Yeah, I'm assuming a turbo because they're very efficient, right? The centrifugal belt-driven ones are also very efficient, but you've got to gear them so that at peak RPM, they're delivering way more air than you want, but you're dumping a lot of it. So in that respect, they get to be inefficient. And at low RPM, they don't necessarily have much boost. So although they can make gobs of horsepower, if they're sized for their range, they're not the most efficient thing to use on the street. Although I bet you they're a lot of fun when they come on the power curve. Watch for tire smoke. But I will, yep, you're asking questions here. Let's go let's analyze this, right? First off, something that's how shall I say, a little awkward about a regular 4-cycle piston engine, right? Oh, I'm guessing that Greg's a big motor fan, right? Because his shop's full of them. There's no one turbo motor in sight. But anyway, let's look at the size of the piston and the bore and the stroke. When that piston goes down the bore, it's going to suck in a certain amount of air, whatever the displacement is, less any inefficiencies there are. Now, to suck that air in, you're looking at something which may be that round with a block this tall. With a turbocharger, for the same amount of air going in, you're looking at a impeller about that big and a housing about that big. Now, the turbo can move a lot more air than a piston, rod, and crankshaft in a bore. A lot more. So now we want to convert it to power. It's not very convenient to use a turbine to convert heat energy into power for a car engine, right? It's been tried lots of times. They've used gas turbines. Although you can make a gas turbine out of a turbocharger, right? It's not the best way to do it. On the other hand, a piston in a bore and being pushed down and driving a crank is a very effective way of turning pressure into rotating motion. So here's what we do for the best combination. This is the least weight of engine for the most power per pound of engine and power per cube of engine. We have a turbo to induce the air into the engine because it's very efficient. And we have a piston, rod, and crank assembly to transform the pressure in the cylinders after combustion into power. So that's the way to go, or that's the way to aim, right? So what we could do here, let me give you an example. Let's say we've got an aluminum Buick engine, you know, the 3.5 up to about 4-liter Buick engine. That, with a turbo on it, weighs a lot less than a big block. And it's smaller, more compact. But with 35 to 40 pounds of boost going into it, it can match a big block, normally aspirated, on a 12-to-1 compression easily. And I'm talking about a 454 big block. So we're talking half the engine size, but more power, less weight. So the turbo route is always the way to go. That's one of the reasons aircraft engines are always supercharged, because the supercharger needed to do the inducing rather than the engine itself, because that was a more convenient package weight-wise and size-wise. Also, by gearing the supercharger and having a gearbox on it so it could shift gears, two-stage supercharger, you could maintain power further up. So that's the way to go with a turbo motor, and that's how you need to look at it. Or in fact, any supercharged engine. And I think I said this last time, the Magnuson supercharger is very efficient. It will do the same thing. Very small and compact engine, boosted, equals a big engine, but with less weight and less size. Usually more efficient in terms of specific fuel consumption, right? So any questions on that? Just wondering about, I'm looking at where we're going down here. That's what I said. Lightweight motor, you get much better fuel efficiency when running at cruise since you're not having to turn a massive engine on. Yes, exactly. I didn't get that. Higher static and dynamic compression ratio with an Otto cycle engine as compared to a smaller Brayton cycle engine that is not at full power. Brayton, I'm not sure. Do you know what a Brayton cycle engine is?
Not sure.
Or is that a misspelling? Well, we'll leave that for a moment. We got a good day from Australia there. Thank you. Yes, Brettine Horn 8507. Apparently, polishing ports is minimal returns compared with porting. Look, fellas, I've said this lots of times. The polish on the ports has almost no positive influence at all, and very often it's negative because the fuel sticks to it easier, right? It's not going to win you any competitions. It's all about shape and a reasonable finish. Now, talking about competitions, most of you know that there's going to be an race engine challenge starting off on the 16th. Greg is going to fill you in. Go.
All right. Yes, we have a contest. We call it Race Engine Challenge. We have different rules of different contests. This is the Classic Rivals. And what that is, it's Chevy versus Ford versus Mopar. But you have to have what we call classic architecture, meaning if you're Chevy, you got to have a 23-degree head, any aftermarket cylinder head, but it's got to be 23 degrees. Ford Windsor, 20 degrees. And Mopar, 18 degrees. That's where they made them. Again, any aftermarket cylinder head. 410 max cubic inches. Why that? Because, well, a 408 stroke or small block Chevy, very common. 408 stroke or Mopar, very common. Windsor, not as common, but they're still out there.
It's still easy to do, isn't it?
Yeah, they're more likely to be maybe 427, but a 408 is still out there quite often.
Yeah.
11-to-1 compression. We call it classic architecture wrapped in modern technology. You can have fuel injection carburetor, coil on plug, roller camshaft, anything else that's modern, but it's got to have that classic architecture. So we have 16th. That's his next week from Thursday, Friday, and Saturday. We have
a single 4-barrel. We omitted that.
Well, you can have a single 4-barrel, or you can have a fuel injection.
Yeah, but that'd be a single 4-barrel injection.
No, well,
or it could be inline 4-barrel, right?
Well, it just has to
be one monster one.
Like I have a throttle body on my engine, which got 2 oval-shaped butterflies.
Yeah.
2 oval-shaped butterflies.
Yeah.
Probably about a 1300 CFM.
It's a 4150 style.
It's a 4150 Gulf pattern. That's correct.
Yeah, Dominator's not allowed, right?
Well, actually, we did change that to say any 4 Venturi carburetor permitted.
So okay, Dominator.
I'm not so sure in this power range a Dominator is going to be.
I think it's right on that borderline, right?
Yeah, maybe. I mean, last time the engines were right about 650 horsepower, and right close to 550 pound-feet of torque. That's we had this last April. The engines that were there, that's roughly what they made. So it should be pretty much the same. Now, what we're going to do, we've already had somebody drop out of the contest because it always happens.
Yep.
Back in the Engine Master days, people didn't get their parts or something went wrong. And it happens. Yeah. And I'm afraid we have someone else I just heard from today who they may have to drop out. So we started off with 9 people, and there was 3 in each class. And this is a Mopar, local guy. The camshaft apparently was ground wrong. Mopar has different lift-to-bore angles, and I'm not that familiar with Mopar. Is we okay there?
Yeah, I'm gonna obliterate that.
So it's I don't think they're going to be able to straighten that out. So
yeah, And you know what the worst part of it is? When Greg's Chevrolet entrant dropped out, I foolishly volunteered to put my 396 together.
No, I didn't. I never dropped out.
No, your one of your Chevrolet entrants dropped out.
Oh yeah, right. The other guy. Yes, yes.
Yeah. And so now it's a panic to get it all done. I have been calling in for parts, and just before we got online here, I was working out my camshaft spec for it. And would you believe none of the parts I've got will fit it? So I've got to get a special made up, see if I can get it done in time. Otherwise, I'm going to be drastically short of lift.
Yeah, that's a lift rule of
715.
715 cold. In other words,
Is that with no lash?
No, that's when your engine is cold. You measure the lift.
Right.
When the engine's
So that's
cold.
with whatever lash it's
Whatever
got.
lash, right?
Right. Well,
That's the way you're going to run
with,
it. That's
with
the way you're
the
going to run
parts I've got, I can't get more than 650 lift.
Mhm.
Right. I've got a great set of rockers there. It's like none of the parts are quite right. Right. And I've got approximately, it's going to be the 8th tomorrow. We're on the dyno in the 19th, right? I've got 11 days to get this engine finished.
16, 17. So, well, we have the 16th. That's Thursday, Friday, Saturday. Now, I'm the only fuel injection, apparently. I got a port fuel injector with, again, it's got two kind of oval-shaped butterflies in there. I guess about a 1300 CFM. Everyone else apparently is carbureted. I'm a fuel injection guy, so I think carburetors actually might have an advantage in a contest.
Yes,
like this.
yes. I've gone with a carburetor here simply because either the Holley Pro, the race 4150s there, plus the new Edelbrock carburetor, plus AED have consistently shown better results by just a nudgers. Now that's a calibrated US standard nudgers,
Yeah.
right? So now I would like to go with fuel injection, but with just, what I say, 11 days to get it done?
Yeah.
No way.
Now, you can go to the raceenginechallenge.com, and on that webpage is all the rules
Yep.
that we just talked about.
All the rules. Right.
Those are what we talked about are the main rules.
Yeah.
But now, anyone who's somewhat local, you want to come over for 1, 2, 3 days and hang around other gearheads, come on over. We're going to ask for $25 just to help offset some expenses. But you can come for 1 day, all 3 days, and hang around all you want, and stick your nose in the dyno room as we're swapping engines. And we have a screen set up, so you don't have to be in the dyno control room to see what the screen will say after the pull. There's a space in the next bay next door. We have a screen up there which we can transfer whatever's being shown on the dyno screen after the pull. We can show that to anyone who's in the next bay. So you're local, you want to have some fun and hang out with other gearheads, come on over.
Andy will be there. I will be there to sign books. Now I won't be I'm not in a good enough state to be doing much in the workshop, right? Anything bigger than a screwdriver, and I've got to think twice about picking it up. But here's the thing. I will be outside under the awning there in case it rains.
Well, actually, yeah, by the way, the 10-day forecast, and 10-day forecasts are getting pretty accurate these days. It's looking pretty good weather-wise so far.
Yeah, well,
No doubt.
we had a very good weather forecast system when I lived in Tucson, right? Arizona. It's how it went. Today it will be light. Tonight it will be dark.
Well,
and the weather forecast.
It's looking pretty. It's looking promising because we have a drought, and but right now the 10-day forecast it's looking good. So let's keep our fingers crossed. Wouldn't be fun in the pouring rain. Wouldn't be fun, but
no,
it's looking good. It's looking good.
Are you going to get an auxiliary tent?
Well, and we have a carport out there, carport, And we have the bay next door, like I said, where that screen is going to be, if you want to view that. And there'll be another shop door open, so there'll be plenty of way to.
No, we're gonna have 50 people there, right?
I don't think we're gonna have 50.
Yeah, come on, guys, we're gonna have 50 people there. Oh, by the way, I will be signing autographs on the books, and I might just bring along a few books that you can buy, right? And I will sign them and dedicate them. Now, as soon as you buy them, if you keep them in perfect nick, as soon as I've signed them, you could sell those on eBay for $25 to $50 more than I paid for them. If you kept them for 10 years, if we go back, some of my books that are 10 years old, well, one book, nitrous oxide book I did, sold for $1,000, and that was about 8 years ago. So they do appreciate in value. So it's an investment as much as anything. You're going to invest in your knowledge and your bank balance. Now,
let me add that it's in Charlotte. The address is 4913 Chastain Avenue.
Yeah, just off the freeway.
For those who are familiar with the Charlotte area, that is like right off of
Billy Graham.
Interstate 77 and Billy Graham Parkway, Billy Graham Parkway. If you're familiar with the Charlotte area, it's about a quarter of a mile off that. So
I was going to say, you got about a 400-yard drive from the freeway.
Yeah,
or Billy Graham Parkway,
77
to Greg's shop, right? And basically,
Billy Graham Parkway turns into Woodlawn Road. We're about not much more than a quarter of a mile off of 77.
No,
a little bit more. That's
yes,
so very convenient to get to.
And there is plenty of parking space.
Plenty of parking.
Yep, there's hotels all around. You can park in the car.
Restaurants, drugstore, you name it. Once you park your car, you don't need to get back into it.
Now, got a point here. First responder garage. Supercharging and turbos are going to be a thing of the past soon with compressed air charging. Sorry, compressed air charging, you've only got a range of a couple of miles at the most, right? That's people will buy electric cars long before they'll buy a compressed air car. Great for drag racing, but not necessary for anything else. Now, let me make a point here, right? Don't forget, with a very efficient supercharger or turbocharger, the horsepower to drive the turbos, or the power loss driving the turbos or the compressor, is regained on the induction stroke, right? If you're pumping 30 pounds of boost into a car, that's 45 pounds total. When that piston intake valve opens, there's going to be 45 pounds pushing that piston, 30 pounds above atmospheric, pushing that piston down all the way down the bore, right? That is a power stroke as well as an intake stroke. So you get the normal power stroke, boom, then you get the other one, which is so much of the power that you thought you lost is recouped. Now, if you look at the GMC blowers, the 675, 875 range of blowers, they're not very efficient. They were not designed to supercharge engines. They were originally designed by the Roots brothers to pump air into mines, right? It's like a question of get it made and let the guys breathe instead of suffocating down there and clear out any gases. So no, where compressed air is not going to, the amount of energy you can compress into an air bottle is way less than the amount of energy you can get in an equivalent battery, right? So electric will beat the compressed air long before anything else. So, okay, sorry to put a pin in your balloon there. Greg.
Let me also say, We're going to have another competition this October. The dates are on the webpage also. Same rules as what we're doing now. Anyone who participates next week, they get first choice coming back in the fall. But I'm sure there'll be a few open slots for anyone else who wants to jump in.
Yeah.
In October.
Greg.
Same rules.
I'm going to make a request here, right? There's a whole load of people building 383s and 396s, right? Can we include them?
Well, you'd have to change the rules.
All you got to do is allow us smaller.
Well, if someone wants to, you could, yeah. If you want to have
right.
Handicap. Yeah, I mean, somebody could, I suppose. It's just
right.
Well,
then you won't have you will eliminate the problem of entries. Plus, if we do that, I've got 2 engines I could get ready.
Yeah, 406 or 408 small block Chevy is so common.
Well, this would be a 394 small block Ford.
That's close. A Ford. That's close. That's close.
Right.
That's fine. It doesn't have to be 408 or 409 cubic inches.
No, but I would like the rules to be put down there so there's some.
No. All it says is max. It doesn't say minimum.
No, I realize that. But the way you've got it now, the engines are not rated on how much they made per cubic inch.
No, right. Everyone was within 1 or 2 cubic inches.
Right. So I'm going to have to forfeit 394, 6, and 8 is 14 cubic.
Yeah.
Okay.
Yeah, that's yeah. You had a great
okay, I've got the parts where I can't afford to buy another crank and block, so that's what we got to do.
What kind of cylinder heads you have?
Oh, I've got some trick heads, and no, they're top secret.
Is this a Chevy or Ford? You're talking
this
about?
one's a Chevy here, the 396.
This one right there.
There, and you want to go and get one of the heads? Is just down by the vice.
No, that's all right. What brand?
You can show the.
What brand are they?
Absolutely untouched airflow research heads.
What airflow?
Well, go and grab a head.
Well, I mean, what's the number? They have their 195, the 210.
They're 210. No, by the vice, round the corner. No, round the corner, out there, round the corner, by the vice and the little bench in the corner there. Go past the jack. On your right. He still hasn't got a good idea of which is left and right. Yeah. Pull it out the bag and bring one over. Right now, my entry for Greg's thing, my 11-day to doomsday entry, is literally the parts I have. This was going to be an engine for a street car, and it was going to have a hydraulic roller in it. Right, when I find out we can use solids, I put in an appropriate cam. But other than that, this is satisfies two needs. One, it's a dyno mule for testing different kinds of induction systems, including a tunnel ram with lots of different tops on it or sides, right? And instead of having just an open plenum, I've got a plate that I want to test to see how much difference the power is where it directs the air into the top of the ram stacks. Instead of it going like this and get suddenly sucked down like that, the top of the ram stacks are curved more and more as it goes towards the front. Right, so show the folks that. Right, there's nothing special except it's just a nice cylinder head.
Oh, yeah.
Right, 2 1/8 intake, 1.6 exhaust, CNC.
No, these are probably two 100, I think, intakes. I think
two and an eighth.
Either 280, one or the other.
No, I just measured them. There's the calipers. You can measure them if you like.
Mm-hmm. No, it's pretty cylinder head.
Yeah, don't tear the bench.
Pretty cylinder head.
Yeah, and it's all stock position ports and all that. I've used a lot of airflow research heads. They just do a nice job, right? Very professional, good quality castings, right? And I'm in a position to plump these straight on. What am I hoping to make? Something competitive, but I'm going to have to pull something out of the bag with this because, well, to be quite honest, with this head on it and the cam that I'm using, I'm expecting to see somewhere around about 630 horsepower and maybe about 555 foot-pounds of torque. But here's the thing.
I think
What does it come out at?
it's like 100.
100? No, it's 125. Right.
I think it's 100. Yeah. That's it. I mean, it's the CNC is pretty.
Yeah. What was I going to say then? See, memory shortage. Greg, you're out of the picture.
Yeah, I think it's probably 100. Nice cylinder head.
Yep. It's a nice cylinder head, right? I'm going to use Crane rockers on it, a set that I've had for 15, 16, maybe 17 years now. They have a roller tip on them, but they have a plain bearing on the trunnion. And it's made of a ceramic plastic mix. The wear on it is non-existent. Now, this is the thing. I've used them on, I don't know how many engines, right? And they still look like brand new. You cannot see anywhere on those rockers. And right now, I'm very loath to sell them, even though, who knows, I might not be able to use them for very much longer. But I'm going to put those on here because I've got them. They're great rockers. But I really needed something around about 1.75 for this. And they're only like 1.6.
You can get 1.7s.
I know I can get them, but I've got those at 1.65. And they're very rigid. So I'm hoping that makes up for everything.
These are the roller springs, I say.
Yeah. So anyway, tomorrow I'm going to be on the phone to Chris Potter at Comp Cams with the event timing I want and ask him if he's got a profile. My Comp Cams profile in my program is probably updated 5 years ago. And I found out when I was talking to Chris Potter, they haven't updated their paper catalog or the catalog they've got for the last, I think he said 2 years. I stand to be corrected if I'm wrong. But the cam profile we used on Green Monster had one of Billy Godbold's new, I forget what they're calling it, right? I'm calling it soft touch. Assuming everything's accurate and the system set up right, it has the tendency to put the valve down more gentle and with less vibrations throughout the lift range. So it should run smoother. Now, we are now talking about very, very small amounts. So the cam has to be ground very accurately to take advantage of the design. Anyway, the beauty of it is when we did the cam for the Green Monster, the big block cam, with the same event timing and the same acceleration rates, Billy managed to get something like 25 thousandths more lift. And that's for free, right? Virtually unchanged dynamic properties, except they were better. So I'm going to see if he's got one of those. If not, I'll have to be stuck with a 600, what did I say, 650? Mm-hmm. Whereas if he's got a better profile, we might get near 675, right? So that's that good. Stepside Deluxe, planning on being there, right? Well, you haven't got very far to drive then. Right.
By the way, the schedule is first engine is 9 o'clock Thursday morning. Second engine's at 12. Third engine is 3 o'clock. trying to do 3 engines a day, which would be pretty easy to do. In the past, when we had a contest back in 18 and 19, we did 4 engines a day. We've learned a few things to speed things up. So
Yeah.
it's, but yeah, we started, first engine kicks off at 9 o'clock.
Okay, not sure 723. Question, DV, have you ever experimented with asymmetric top cuts? Like 30-degree on the front of the valve and 40-degree on the back. Now, I know what you mean by asymmetric, but I'm not sure which top cuts you mean. Are you talking about round the circumference? Because don't forget the valve rotates. 30 degrees on the front or 40 degrees on the back. Right, I see what you're asking now. Actually, mostly when I'm doing a special motor for me, on the front face of the valve, I do a conformation ditch, which also acts as an anti-reversion thing, right? You'll know all about that if you've got my cylinder head book. And on the back, the seat angle, I do various angles depending on what it's for. If it's a short cam motor and we want to make the best of it, I actually use a 30-degree seat there, right? Because it looks like the rate of opening initially is way faster, something like the amount of space between the seat and the valve, or the area around the valve, increases much faster with a 30-degree seat. It's something like 20% more. And so it looks like a bigger valve, but with no more shrouding, right? That's the deal there. Now, if you use a 30-degree seat, you've got to cut it really accurately because it does not slide down the seat as easy as a 45 or 50. Also, to make sure that it does seat, it needs to be a fine finish, and you need to use maybe 20 pounds more of seat preload, right? So using a 30-degree seat can be kind of dodgy unless you get everything absolutely right. Oh, and that said, you can't just do a 30-degree seat instead of a 45 and swap heads and expect it to work. It won't. The increasing flow potential at low lift is so big, it totally screws up your lobe centerline angle. What you've got to do is make the lobe centerline angle about 2, sometimes 3 degrees wider, because the engine thinks your valve has got 1/4 of an inch bigger. That's a big change, right? Okay, on with that. You got anything to tell? Oh, Greg, have you told the folks about your intake manifold where you used the 4-barrel Victor manifold, and this is for the LS, and then you made a top for it?
Oh yeah, well you'd have to have a picture of it though.
Yeah.
Pictures worth 1,000 words.
But
yeah.
Now, the thing is when they tested it comp, right, you virtually matched within a very small amount what
there
their
was a
fancy
single turbocharged LS engine, and they had their new manifold they hadn't even released yet. It looks like a pregnant beetle as far as I'm concerned. And of course, you couldn't close your hood if you had a Camaro.
Minor detail.
Minor detail. And mine is low profile. And on the turbo, with their manifold, it made like 1,060 or something like that. And that was 40 horsepower or less. But that percentage-wise, 40 horsepower when you're up in 1,000 is pretty small, and you can close your hood. So theirs is, it's the top came off, and you had these runners that stuck up like that. I mean, there was no limits as far as in the design whether you could close your hood or not. I mean, it's just design a manifold and you make it work. So yeah, I still have. And actually, one other thing we're thinking about doing is. Maybe because I have an engine that I did for the Engine Masters days, God knows, about
7 years ago, now 8 years ago.
12, 13 years ago.
Is it that much?
Yeah, it was when they had an SP2. Having got an SP2 engine, I'd like to have an SP2 versus Cleveland versus LS. I thought that'd be a good competition. because I got an engine I could dust off and just roll in and have LS versus SP2 versus Cleveland, and 427 cubic inch max. That would be good. That'd be good.
Yeah. Okay, question here. I think we need to start testing engines which are smaller. Like there's a whole bunch of guys with the small block Fords, 302s, right? I think we should have a competition where we limit, we say it's got to be a 331.
Well, I'll say this: it's very difficult to get people to step up and participate in these things. It's very difficult. I mean, if you had a dozen people that stepped up and wanted to have these kind of rules, I mean, it's very difficult. Talk is cheap. Very few people step up. So you can come up with whatever rules you want, but to get people to really step up and do it.
The only way we can make a lot of people, let's have some comments on this. Only way we can make a lot of people it more favorable for a lot of people is to have the power per cubic inch.
Yeah, then you're not limited to the cubic inches. Yeah, let's like back to the engine masters days. It was power.
Yeah. But then you could run a 302 against a.
Well, they had back 18 and 19 when we did it. We had a minimum cubic inches, like I think it was 370 or something like that. We don't want to get it. It's.
Well, we can say, okay.
Not many people are going to build something real small.
There's a lot of guys out there. I get a lot of questions on small block Fords. A lot of guys out there want to build a small block Ford, an 8.2 inch block.
Let's see who steps up.
That says, how about we have a 300 to 350?
Well, let's see who's going to step up and say, I would consider participating if the rules are X, Y, Z. That's what I'd like to see.
Yeah.
It's very hard to get people to really do this.
Think about that, guys. Now, I'm going to answer a couple of the members only here about their asking the questions. Actually, I think if you look at your email, you should have an email, all of you, regarding the head porting concept. Will back cutting the intake valves be permitted? You can reshape the valves so long as the diameter of the stem and the diameter of the head stays the same. When it says reshape it, that's totally free. You can use a 29.5 degree valve seat if you want to. You could use a 60 degree valve seat if you want to. I'd say either of those might be a problem making it work, but there's no limit. However, I would suggest that if you try to make the valve seats too thin, once you get much under about 50 thousandths, the flow will drop off. So don't think, I'm going to have a knife edge around there. No, it will flow like crap. Right? So does that answer the questions for the two of you who sent in on that? So valve seat in the head, valve seat on the valve and the shape of the valve, right up to where it goes into the valve guide, have to be stock size. No, can be modified. It can be any shape, but the diameter must be stock size on both instances. We would love to take part, but we don't have a spare 50K to build a test engine. I don't think anyone's ever come. I know you're probably joking there, but how many of the engines are really expensive? Most of them aren't, are they? I mean, look at what's his name's Chrysler last time. That wasn't an
Well, the small block Chevy and the
right. If we limit the heads and the intake manifolds and things like this, you're hard pushed to spend more than about 15 grand.
Oh, you could definitely do it for less than that.
Yeah,
you can use a
hard
stock block. I'm a big believer in block fill. Maybe not 100% up to the wall inlets, but maybe half a block.
That one's half fill.
Yeah, half fill. That really stiffens up the lower end.
Yep.
Big believer in that.
And here's the other thing: if you're building a street motor and you put in a small block Chevy and you put a half fill in, the noise, mechanical noise of the engine drops substantially. Right? I've noticed there's some engines that have got very heavy blocks, and I'm thinking Pontiac's probably one of them. And even with the same clearance as a small block Chevy, it is much quieter mechanically. But when you fill a small block Chevy block to, say, a half fill, quietens it down, right? Quietens that whole thing down. And here's another thing. If you put on line-to-line coating on there, which allows you to have a fit for fit in the bore, it really quietens them down. It sounds like a Cadillac engine that's not running, right? Really quietens it down. Your biggest noise is the valve train. Right. Good evening. What off-the-shelf muffler would you recommend for a normally aspirated 5.7 V8? Thanks in advance. That's B891. Now, if we're talking about a conventional muffler, right, and we don't want it, we're not looking for the ultimate in sound levels, i.e. low, then the one that's made by Walker, their turbo with the curved baffles in it, works pretty well. It's a little on the loud side for me, but you could put in a straight through muffler on the end, and that'll fix that. Now, I can't remember which one it is, but Walker also have a long straight through glass pack that you might want to look up and see if they've got it. The beauty of it is unbelievably quiet, and it's a big glass pack. It's like 2.5 inches at the smallest diameter. Flows a lot. Very nice sound to it. Bit more expensive, but that's that. Now, other companies that make good mufflers is MagnaFlow. They've got a muffler which is a wire mesh, and that works, and it comes in and across and out like that. That flows good, sounds good.
Somebody made a comment here, don't have $50,000 to build a test engine. That's an exaggeration. I don't know.
Yeah, that's what I said.
No, that's an exaggeration.
Yeah. No, that's what I said.
Oh, yeah, I didn't see it. Yeah, that's an exaggeration.
Are there any spots left in the head? Ron Freedy Jr. Member Ron. Yes, there is. I think there's one left. So if you enter now, you may beat somebody who may want to enter, find out they could enter in half an hour's time. So enter now. Valve, 6 valve angles cannot be changed. Yes, sorry. I generated that confusion. The valve angle in the head is got to be a 23-degree valve angle.
You can't do offset.
Can't change that. In fact, you've got to use the same guides and holes and all that were in the head.
Yeah,
right.
You can't angle mill it.
Ron Freedy, how do I enter
the contest right now?
The head contest.
Oh, head
Ron,
contest.
if you look at the last few videos, it must tell you at least 3 times how to enter, right? If you still have any problems entering, email me on my email that we use for such things, right? That should be up there. But if you have any problems, call me tomorrow on the business only number 704-675-4447. Right. Joe Carroll. After your discussion on exhaust, you have been looking for tri-Y for a street truck. Me and my son are working on. Thanks for the info. No, the exhaust system I was speaking of is not a tri-Y. It is still, it's an uneven length 4-to-1 for a 2-plane crank. I am not thinking that the tri-Ys we have are anything like optimum. They are a flash in the pan, right? I don't think they had any thought behind them except this has worked on 4-cylinder engines and it worked very well. Why wouldn't it work on a V8? Well, it doesn't work on a V8 like a 4-cylinder engine. So not a question that needs to be answered there. But Joe, if you want a bit more advice on that, give me a call and I might be able to give you some pointers on how to get the length right for a 4 uneven length 4-to-1 header, which will be much nearer optimum. Well, shit, I'm not sure what that pertains to. Where's when building a custom ram air intake system, is it possible to make the inlet too large? Oh, hell yeah, most people do that, right? However, it's also just as easy to make it too small. Until I was corrected by my aerodynamicist friend, I used to make the area of the inlet just a bit bigger than the area of the venturis and carburetors, right? And it turns out it needs to be a bit bigger than that. However, some of my sizing on Bonneville cars has worked, right? But we don't know if that was the best. My aerodynamicist guy has a lot more experience than I do. So if I'm going to do any of this next, I'm going to see if there's a ratio that I need to be sticking to. So not a totally, not a quite up to the minute answer on that yet, but it can be too large. If you don't get the induction system right at the snorkel, the power you get extra from ramming the air in is completely eradicated by the extra drag, right? Which is not good. And the drag goes up with the square of the speed. Right. Manitou Black. Thanks to the team for doing this.
Well, I'm going to put a pitch in for engine simulation software. I have Engine Analyzer Pro and Dynamation. They seem to be probably the two most common ones out there. Good data in, good data out. Remarkably close. I simulated the engine. Speaking of this contest, simulated that engine and put it on the dyno, and it was remarkably close. I mean,
yeah, which program?
Well, both of them, both were, and that's another thing. Both of them were very, very close.
Yeah, you're talking about the.
I mean, it's just remarkable how close. So I know they're about $450, $500.
Yeah, I've got both of those.
Can you learn a lot?
Yeah.
By
it's fun to play with, and you don't get your hands greasy, and you don't break parts.
If you want, get a couple of your buddies and split the cost, and you can just.
Yeah.
I'm surprised the amount of people who they keep going. How much power am I going to make with this? How much power am I going to make that one? Well, why don't you find out? You can play with different center lines. I mean, it's just great. One thing that helped with mine, I have AF heads, and AFR heads. They tell you the minimal cross sectional area in that cylinder head, and that was a good piece of information. Then you enter the data from your intake manifold, the area of the intake, the taper that you have. And you learn a lot just by entering the data into the software. I mean, into the computer. It makes you think. It really does. So I'm really surprised more people don't step up to that.
Let me answer this guy here. He's a member. He's a channel member. Just RCNG 3604. Whew. I've never tested a tri-Y that's actually made more horsepower than what is supposedly an equal length 4-to-1 header. When I talk about unequal length headers, I'm talking about scrapping this deal about equal length headers. Oh, you got to get them exactly right. No, if you've got 4 header tubes exactly the same length, you've got at least 3 of them wrong. Could be all 4, but at least 3. Now, usually with the tri-Ys, when used as intended on short or medium length street cams, they usually show up as more foot-pounds right down at the low end.
Well, I can step in here. I've tried tri-Ys.
Now, your tri-Y definition is a competition NASCAR tri-Y,
Okay,
which is
fine.
a different thing altogether.
Well, that's whatever. It's just call it tri-Y.
Yeah.
And it picked the power up around 4,000, 4,500.
Yeah.
It really did.
But let me correct you guys so you don't go wrong here. Greg's tri-Y, although it strictly is a tri-Y, it's better to look at it as a 4-into-2-into-1 system, right? But it's not a tri-Y where you have 2-into-1 short and then 2-into-1 long going into the collector. So you have 3 pipes going into the collector.
No, that's what it is. It really, and it lost about maybe a dozen horsepower up top. But wow, that's a very favorable trade-off.
Yeah, that's what
it was very noticeable. You can overlay that. You can overlay the power curves. Yeah, so
right.
That's
I used that on my cup car engine because I had one. It was made for the engine. It was beautifully made, and what did that make? It was 356 cubes. It made 520 foot-pounds of torque and 728 horsepower, right? And this was about a 2024 cup car engine. Now, when it came out of the engine builder that did it, Jeff Gordon's ex crew chief, what was Jeff Gordon's ex crew chief? He started his own Chrysler deal. Anyway, when it came out, the engine made about 500 foot-pounds and about 740 horsepower. But I put a cam in that was nearly 20 degrees shorter than the one that was in there because I could not afford to keep rebuilding that engine. So I scaled down the RPM at which it ran. Right, what else have we got?
The dyno program
plus torque
horsepower
curves are 99% exactly the same every time. It's a great tool.
I don't understand that question.
It's not a question. He's making a statement. Right? That's one of my members. Right? So
great tool.
He's conferring what you're saying.
The dyno, it's a dyno program called.
Yeah, he's conferring what you're saying.
Okay, all right, yeah. Oh yeah.
Right.
Good data in, good data out. That's what it is. That's what it is.
Yes, well, Passionate Motor Works, that is possible. You're a member. We'll have a private phone conversation on that. Try calling me tomorrow evening-ish, right, on the business-only number, right? And we can do that. You shouldn't have any problem speccing out your cam unless you've got something really oddball, right? Joe Carroll, tri-Y. I was looking at we're from Doug Thorley. not a cup car. Joe, I must be explaining things wrong, and you're just as bad.
Oh, Joe Carroll. We Joe. He was Joe. Weren't you at the PRI show? You stepped over at the the Superflow booth.
Yeah.
And we want you to get you
Look,
to participate.
I was, when I answered your or commented on your deal there, Doug. Sorry, Joe. I was thinking of Doug Thorley headers, the tri-Y that his lordship here was talking about for cup cars wasn't out then, right? Those tri-Y headers that were used on cup cars, I don't know. I can't remember seeing them much before about 1995, 96. I could be wrong, right? But they were relatively new.
So, Joe, if you're watching this, why don't you enter the contest come October? You're a player. You're an old veteran of the Engine Masters.
Yeah.
Come on, Joe, step up.
Well, we'll even frame the rules around your engine. How about that for a deal? Just don't let anyone else know.
No, really.
Right. I'm gonna turn this off again. Keeps coming up. Yes, you met it.
Yep. That's right. All right, Joe. Yeah, give me a call sometime or send me an email. But you got 6 months to get that puppy together.
Okay, John Flett. Have you ever experimented with SpinTech mufflers? Now, if I'm right, these are the ones that have got a spiral inside. Right. I don't know what they're like now, but when I tested them just after they came out, they did not flow worth a darn. Terrible. That's all I can say. Whether they've changed it or not, I don't know. If anyone's got any comments to save the day for them, stick them up here, right? Floyd's Garage. Hi, everyone. Hi, Floyd. Floyd's Garage. Yes, the tri-Y headers. Joe Carroll. I would get my ass kicked. Joe, I'm not sure. I'll tell you what we'll do. The drive shaft has to be made of telephone lines, right? You've got expertise in that area. Floyd, try. Steve's at dusk. Hello, group. John Flett. What's the best way to flow a muffler on a Superflow 600? Well, you can either suck through it or blow through it. Doesn't make much difference, but you will not be able to if you've got something like a glass pack, you may find it'll hit the roof before you put it on the flow bench, right? So you may have to make an adapter, but I would say the best way to do it is to suck through the muffler, right? Because it keeps it on the same method of passing air through it, same direction as a carburetor. And mufflers are calibrated on 1.5 inches of mercury, right? I know that for a fact because I set that standard for SAE.
I'm going to sign off, David. I'm going to run.
Right. Okay. Well, look, 2 minutes. Anybody got any questions for Greg? You got 2 minutes.
2 minutes. All right, 2 minutes. But anyway, if anyone, I'm an old-fashioned guy. Pick the phone up and call. The phone number's on the webpage. If you want, send an email. But any questions, give me a phone call, and we'll talk about what you'd like to enter.
We getting any questions? You got to be quick on this. You got to be quick on those fingers, right? Because there's only 1 minute left. Okay.
Okay.
You can go.
Bye. All right.
Okay. Thank you, Greg.
Talk to you later.
Don't fall over anything on the way out. Okay, folks. Now then, Car Ventures, high DV, big picture question. What determines the theoretical maximum power of an engine? What becomes the limiting factor, e.g. BTU available, compression, etc.? Well, let's exclude a few things here to simplify that. You know, and I'll tell you why. If we made the connecting rods out of balsa wood and the crankshaft out of wire, that's going to limit the power. So let's assume we have a bottom end which can deal with way more than we can, the thermal activity going on in the engine, right? So the simplest thing that you can say that determines how much power can be made is detonation. And detonation is usually brought about by the temperature the exhaust valve runs. So the hotter the exhaust valve is, the more likely it is to detonate. This is why aero engines went to great lengths to cool the exhaust valves so that they could stuff in as much boost as possible. The valves were hollow stemmed and they were cooled by what's the stuff called? God, forgotten. That stuff you put into some of the Corvette valves from 20 years ago have got I keep wanting to say calcium, right? They're cooled. That is the ultimate limitation. If you can keep those valves cool enough so that you don't detonate, then the rest of it becomes a choice between strength of the parts and how much pressure you can actually generate from the blower, right? Because at the end of the day, octane rating of the gasoline itself is not the limitation, because we have water injection, which can put the octane rating up, put the octane rating of the gasoline up to almost infinity, right? An ordinary 87 octane fuel can be boosted to something like 200 octane or 200 power numbers with water injection. Higher than that, it's just ridiculous. And I don't know why more people don't use water injection, right? It's a little inconvenient, but boy, I tell you what, if you want mileage, then you run about a 25-to-1 compression ratio with water injection and all the right stuff, low friction parts here, and you will be getting 35 miles per gallon out of your V8 engine, right? Sodium, thank you guys. Sodium cooled valves. It's solid at normal room temperature, but it liquefies and it bounces up and down inside and conducts the heat from the head into the stem so that the whole stem becomes a outlet for the heat. So if you've got bronze guides on top of that, they need to be close fitting guides, because if you get the clearance too big to avoid seizing, which you shouldn't do, then that cooling effect largely goes. When you clearance those valves, they need to be run. First off, you need to use a certain kind of bronze. And secondly, you need to run it with an oil additive or an oil capable of allowing for close clearances. Most race engine oils do. Without wishing to plug it any more than I do, I put Oil Extreme in, which will almost eliminate oil. Oh, and here's a valve guide that will stand extremely close clearances, and that is the K-line guides, where you hammer them in and then you run a spiral down them, and they're like 15 thousandths thick. And then you put a ball through. My friend Denny in Tucson, I don't know if he's still with us, but because I haven't spoken to him since I had my brain surgery, but he ran an engine on the dyno with zero clearance. The valve would, on the exhaust system, the valve would just push through, no clearance. Ran it for a couple of hours through power cycles and things like that. Came down. Not a sign of any seizing whatsoever. Now, I don't recommend running them zero clearance, right? That was just for an experiment to see how anti-seize they were, and it was very good. But if you can run them with, say, 1,000th clearance and a drop of oil extreme in, those valves will cool very well. Those sodium valves will cool very well, much better than just a regular valve. So there's that. Wasn't it some kind of salt? Well, yeah, that's right. Sodium is a salt. Floyd's Garage. Oh, yeah. Honda uses sodium filters. Right. Yep. Floyd's Garage, Inconel. That is a material to make valves out of. Very good. Very expensive, right? These days, it's still in good use, but these days, there's materials which, as I understand it, the last I looked into it, were cheaper than Inconel, slightly lighter, and almost as good. John Flett, yes. Would it be possible to use low pressure area in the back of the car to pull air through a radiator mounted above the rear axle, drawing air from under the car? First, John, why are you using a car with a back axle? It should be independent. I love the independent suspension on my Mustang. Whoa, it's so much better than that live axle that I got on my two other older Mustangs. Anyway, yes, that is a very sound idea. The aerodynamics for it takes a little bit of work, and you might need to make some models you can use plastic models and make an airstream in a tube blowing through it with a vacuum cleaner. And then a bit of smoke in there and you'll see where the air is going. It's got to come whistling out the back of the car just about as fast as you would imagine it going in, right? You get that done and two things will happen. One, you'll get downforce on the back, very effective downforce. And two, you'll cool the air. And three, you will probably cut the drag if you put the radiator at the back as well, because you don't need air going in through the grill at the front. What goes underneath the car is more than enough, right? Let me show you. This is the car I built in 1971, which had a tunnel design. Underneath was a tunnel and it came up. And you see it's a Ford Anglia with the notch back here. No, here. The notch back there. That trunk had a hole in it that was a rectangular hole, which was about got to be getting on for 3 feet wide by about a foot. And the tunnel went down and it scooped up air from underneath the car. That sucked the car down like you wouldn't believe. And it relieved. We had this hood vent. Now, this is when we had the single carb on there. Later on, I put two 44 IDFs on there. And we let air out there as well. We had to block off a lot of the radiators to get the engine warm. It put so much more air through there, and it was faster down the straight at Silverstone. Right, this is on the club circuit. The straight was probably, I don't know, about a half a mile long. And you came onto it at about, well, in that, I came onto it at about 45 miles an hour. Everyone else was nearer about 40. And it was faster. We picked up about 4 miles per hour down the straight. 1,000 cc with the two fours on it. the two barrels on it, Weber carbs, on the dyno owned by the big filter company in England, oil filter company, forgotten its. Anyway, it made 139 horsepower at about 10,500 RPM, but it pulled around to 11.5. Boy, did that thing scream. Really, really, you could hear it all around the club circuit. Every gear change that was made, everything. Now, Colin, my crew chief, drove the car there, and he was a really good driver, right? Anyway, car faster than 10.99 weight over 210 must use a conventional differential housing rather than a swing axle, right? Yes, well, you know, that's a problem, right? If I was designing a rear suspension for a drag car with no silly rules about axles and that, I would have the diff mounted solidly to the chassis. Drive shafts going down. After all, you have a drive shaft coming into it, right? So what about two drive shafts coming out? There's no reason why they can't be as strong or stronger than the one going in. So that rule is kind of dodgy. Then you don't have independent suspension at the back. You have what's called a Dion rear axle. It's a tube which goes across to both axles, but the diff is here. The tube drops down underneath it, so you can have the identical traction geometry for the back axle. But here's the thing. Our rear suspension works by virtue of the weight of the car thrusting the axle down. Well, let's imagine the axle weighed, all the weight of the back end of the car was in the axle, and the body up here weighed nothing. So when it transferred weight, nothing extra went to the axle. Now, turn it around the other way. Let's say our unsprung weight on the axle is nothing, and all the weight is in the car. Now, when it transfers weight, it transfers the maximum weight possible. So that will give you the maximum off the line traction, right? Consistent with whatever traction your tires give. So what we've got there is, by putting the axle housing, that heavy mother, right, and mounting it to the car, and having only half the weight of the axle shafts, and having this super lightweight axle, which may only weigh 10 pounds, you will have way better off the line start. I say way better. That's in terms of the strategy that could be, that's in terms of the advantages that could be gained by virtue of the state of art as it exists now with the live axle, right? So that's my piece on live axles. Did you put scoops under the car? Yes. They dropped down about, well, I don't know if you can see them there. You see where the rocker panel is there. They dropped down about 2.5, maybe 3 inches lower than that. They cleared the ground by only about this much. Right? Now you might say, well, how did you avoid making them hit the ground? Plenty of anti-dive, both front and back. So when you put the brakes on, the car didn't really settle down on the suspension very much, right? I know I had one problem which I was worried about, and that was curbing it when I went over the curb, because, you know, if I can find a way over a curb, that's where I'm going, where there's no one else there. And I built the car just to ride curbs. But I found that what would happen is I could put enough speed in there that it would hit the curb and bounce up. And by the time it came back down again, I'm on open road again, so it wasn't a problem. However, I did hit my exhaust on it once, right? Actually, once. I only drove the car twice. Colin drove it the rest of the time. Bent the exhaust and it burnt all the paint off the inside of the car. I thought I was on fire. I pulled the fire extinguisher, made no difference. You know why? It wasn't actually on fire. It was just baking the paint inside. I didn't know that's where it was coming from. So it filled the car with smoke. I mean, I could not see where I was going for a moment. And anyway, that caused a big laugh when it came in. They threw water over me and the inside of the car when I pulled up in. So I did not overheat in my race overalls because they were sodden wet for the rest of the race. Thought you might like to know that. Forgive me for my question. Have you had any experience with an inertia dyno for small engines? How reliable, repeatable are they? Yes. I believe that 2 dynos that I've made, I've made about 4 all told. 2 dynos that I made, one was just a torque dyno, which had to measure the torque of servo motors for automatic pilots, had to measure the torque within fractions of a gram centimeter, and also a totally inertial dyno to test valves for Cosworth, valves and pistons for Cosworth. And the only way we could do that sensitive enough was to make an inertial dyno which ran a single cylinder 200cc Briggs and Stratton engine. Now, it had all the good parts in it, other than the valves, which were made of, that's secret, and the pistons, which were made of, and that's secret. And that was totally inertial. It would measure within 1/100th of a horsepower. Now, you might say, well, the bearings in it would shatter that. The bearings that the whole thing rested on had 0 torque absorption. I'll let you worry about how that's done. But yes, and here's the thing. It was deadly accurate, and you do not, the beauty of it is the engine itself becomes the means of dissipating the power after you've made a run. So you don't need a radiator. You can put this in the middle of a car park and run it with no connections to water or electricity other than having a battery on it to start the engine. Right. So yes, I have had a great deal of that experience of that. Okay, John, that's John Flat. Could I mount the undercar scoops to the rear lower control arms? That way they wouldn't get any closer to the ground with suspension travel. Well, that's very true. I had not investigated that. That would be important if you were building an off-road car or one that was, needed to negotiate big bumps. But when I did my Anglia there, it was exclusively for road courses, not bumpy tracks. So I think that might be a good idea, but you might have to look at everything there to see that it all get in and how you're going to connect it all up. It might get a bit awkward, right? It's up to you to decide. It's possible, but I'm sure you can think a way through it. But I can't give you any other advice than what I've just said going forward on that. Right, let's see what else we've got here. Anybody else got questions? In the original, that opening I put in, we'd have questions on something else as well, and I've forgotten what it is. Yeah. I gotta say here, Floyd, that we've had gauges mounted on the fuel rail on the engine in a very hot circumstances on the dyno, and we've had fuel pressure gauges mounted 20 feet away in the cool air, and I can't really recall with them showing any difference. The fuel is going to get heated up anyway, so will it damage the gauges? I don't think so, but I couldn't give you a definitive answer to that. My thought is probably not. And it might be a good idea if somebody else throws their 10 cents in there. Have you tested compression ratio on a 2-barrel engine and can go above 14:1 without losing power? It's on methanol 360 something cubic, 360 something cubic, 2-barrel 560. You should be able to run more than 14:1 if it's on methanol, right? Let me tell you something about methanol. Does the class ask for pure methanol? Right, no additives in the methanol. Answer me that before I answer that question there. That's Chevy RC. Oh, you're a radio control guy, 3623, right? Am I interpreting that right? While I'm waiting for that to come up, Chance 4231, have you done any work with an Oldsmobile V8? Yes, a friend of mine and I built one. It was his engine. I helped him build it, and I've modified probably only about 5 pairs of heads in my life, Oldsmobile ones. And I think that probably 3 sets of those were the aluminum ones, right? Chevy RC. Yes, pure, you've got to run pure methanol. Right, that's a shame. I race wingless spec sprint car. Let me ask you a question here. This is Chevy RC 3623. Can you put a lubricant into the methanol? Right? Answer me that before we go any further. Trey Avery. I love the idea of porting heads, but I'm somewhat hesitant to simply because of my lack of technology to measure how my port is affecting the flow. Is your advice to not because of this limitation? Look, Trey, it is so simple to check whether you're getting better or worse. It really is, right? Here's a way you can do it. Get your mom's vacuum cleaner. Modify the end of it so that it fits on the end of the intake port, right? Not delving into it, but put a flange on it so you can push it on and push it up to the end. You really want what's going in there to be about the same shape as the port. You might be able to take one of those things that goes down to an oval and cut it up and get it to near fit. It doesn't matter, so it's the same every time. Put clay around it, then get your valve, and let's say you want to check how much flow it's got at 1/8 of an inch. Oh, you put a manometer. All that's got to be is a pipe going into the pressure, into the vacuum cleaner, comes up, goes down like this and back up again, and you fill it with water to the halfway up the tube, the U part of the tube, and put the valve in, open it to a certain amount, switch on the vacuum cleaner, see where it comes, turn it off, cut a bit out of the port, put the valve back in the same place, switch on the vacuum cleaner. If you've improved it, that pressure drop will drop. The biggest pressure drop occurs when the flow is worst, right? That is totally consistent. You do not need to have CFM. If you've got that vacuum cleaner and that deal there, you have all the equipment necessary to do a job as good as a guy with a $6,000 vacuum, $6,000 flow wrench. Buy my book. It shows you how to do it in there. You can build your own, in quotes, flow measuring device for, if you borrow a vacuum cleaner, all you need is a cylinder the size of the bore and a means of mounting that on the head, right? Buy my book. You can get that. That's how to port cylinder heads, how to airflow and port cylinder heads for performance. And that comes from Amazon.com. I think it's $28. What about mounting the regulator before or after the carb? See a lot of discussions about that. You know, you mean dumping excess pressure after the carb or restricting it before? You know, if done properly, I have never seen a difference between the two, right? I prefer to have the not blocking up the pressure and dropping the pressure before the carburetor, because it puts more strain on the mechanism than letting it flow back to the tank. Also, flowing back to the tank and limiting the pressure by virtue of the amount of flow means that your fuel gets cooled better, right? And so that's how I do that. Now, when we were running turbo motors, the fuel temperature was quite influential, especially when it went in before the turbo, or when it went in to the manifold. So what we would do is vent the pressure gauge back to the tank, and we would have the fuel ice cold. It would be in the freezer the night before. So it'd be down to a temperature of -20 Fahrenheit, maybe more than that. And we had enough horsepower from the engines, usually where we needed to carry a little weight in the back, because otherwise it was wheel spin. So if we were going to use, say, 4 gallons in the race, we would put in 10 gallons. So that extra weight would be there. And pumping it back, and that fuel was still pretty cold by the time. It wasn't freezing, but it wasn't hot. So that's a point you might want to do. Also, if you are turboing a motor and the turbo is restricted in size, so that, and your intercooler is restricted in size, it is best to run fuel in which you boil off the high-end hydrocarbons, the ones that are going to evaporate first. You can boil off 20% of your fuel. Bad for emissions. Do that in a tank. But if you're like we were with the Cosworth British touring car once, that was a solid 25 horsepower. And when they come to test your fuel, they get all angry because it's not what was brewed. And then you point out to them, it doesn't say anything about taking out of the fuel. It just says you can't put anything in. It's legal. I get into trouble with guys, scrutineers, tech inspectors, for interpreting the rules exactly. Shane G. Wouldn't be Shane Ginsburg, would it? I'll watch that guy drive. Hot stuff. Yes, I made extensive use of phone. I can't remember which one I used, but it really needs to be one that can deal with 300 degrees Fahrenheit. So look on the can to see what it will deal with. You can get ones that are 280 degrees, and I found that a couple of the brands that say 280 will go to 300, but I can't remember which one. They've changed their labels since then. All got bought up, whatever. You'll have to find out for yourself. Just buy a couple, put them on a hot plate at 280 degrees and see what happens. Scott C, 74. I've seen where people had a problem with a liquid fuel pressure gauge reading different when hot to cold, right? You know what? I've never looked for that problem, so I can't recall ever seeing that being a problem, but I can imagine that it could be. So other than that, I can't really fill you in on any more detail. Chance 4231. David, do you remember if you did big block or small block Oldsmobile work? I did one Oldsmobile, was a big one, and I can't remember how many inches it was, 400 and something. I'm trying not to confuse it with a 455 Pontiac, right? Which I only did one, helped up out on another one. Yeah, the one I helped out on, I did with a friend of mine, and that one was exhibited at PRI. What was SEMA? I can't remember which. Had 450 downdrafted Lortos on it. God, it looked good. Made big torque numbers, good horsepower, but it was strictly well, not strictly. It made good horsepower, plenty enough to smoke the tires, but principally it had to look good, and it sure did. I think it was around about 550 horsepower, which made your typical hot rod whole ass, but the torque, it was about 11-to-1 compression, and I think we were seeing about just shy of 1.4 foot-pounds per cube. Right, so it was good there. It was a good solid 600 foot-pounds anyway. Was trying to help out on the fuel pressure regular question. Right. Where did you put up there? Yeah, if I just Scott, yeah. Yes. Like I said, Scott, I have not remembered experiencing what you're saying happened here. I can believe that the temperature may well affect it, but I have not seen that. That doesn't mean it doesn't happen. I've not seen it, right? And it's a point well worth noting. I'm going to pay attention to that the next time I set something up, see if it happens. Thank you for bringing it up. Oh, when you say, have you tried, not sure, sandblasting balls, you mean fuel balls? Yes. No, I was thinking you meant fuel balls. You mean the bowl underneath the valve. I tend not to use shiny finishes there, right? So yes, I very often have sandblasted the bowls, especially as they look better than my early grinding work. But these days, I'm finding it's not as important to have a coarse finish there, because the carburetors we have got in the last 15 years do a far better job of having a across the board better atomization. In other words, they're the peak of the large drops, no, let me rephrase that. The large droplets have diminished in number and been replaced by a far greater number of finer drops, and they tend to follow the airflow. Once the fuel droplets get down to less than about 5 microns, it might as well be a gas. Where the airflow goes, the fuel goes. And this is much more the case with modern carburetors. I mean, your typical carburetors that I mentioned just a while back do a great job of that. And I have a sneaking suspicion this is why they so very often give better power outputs than fuel injection. Because the fuel injection, the last time I checked it, note that, last time I checked it, tended to have a patch in the middle, which was coarser than maybe we need. And I think that's why they very often don't. Because you can get the mixture anywhere you want with a fuel injection. You just tell it what you want it to do. With a carburetor, did you know all carburetors are female? You have to persuade them to do what you want. Big difference. Hey, Andy. It's Andy's birthday today. He's just been spoiled by his wife, Mandy, right? And I bet you he was spoiled. Where is he? I've lost it. Yes, it was Andy's birthday. Wish him happy birthday. He's 21 today. You must not be Shane Ginsburg, Shane G, G9K. And you're 48 now. You're a youngster, right? I'm almost double your age. Chance 43. Hope you had a good time. And that's for Andy. Yes, Andy knows how to party. Trust me. Yes. It has to be a terribly bad party if he's not the life and soul of it. Oh boy, you're getting plenty of responses here, Andy. It's going off the end here. Right. So, okay. Any more questions? Oh, I forgot to stop and say what I forgot to put in what I was going to say when I asked whether the alcohol could have oil in it or whether it could have anything else. If you are running an alcohol motor, when we ran a Sprinter, the rules said you could not have any oxygen-bearing additive in the methanol, right? So that outlawed any nitro something or other. But what we did find, especially in the cooler weather and when it was moist, plenty of moisture in the air, which not good for an alcohol car. What we found was that if you put some quick, I'm trying to think of it here. That's what happens when you get old. It's not good for wusses, you know. Two things we put in. One is an additive which everyone will tell you never put in. That is that stuff they originally used as an anesthetic, right? It's got an octane rating of about 1. Not quite, but it's very low. Detonates very easy, but it also evaporates and is a great ignition enhancer. Now, put too much in and you'll lose power and the engine may detonate. But if you put just the right amount in, and that's about, depending on how damp it is and how cold it is, 1 to 2%, your engine will fire up just like that. And there's another one too to put in. Sorry, guys. We'll have to tackle that next time. We're on, which should be Friday. What can you do about crankcase pressure? Well, you've got to get rid of it, that's for sure. Now, doing the crankcase pressure with an exhaust-driven one, if that's allowed, is really easy. However, I don't know why this is, but I see literally hundreds of them mounted the wrong way. And then when I looked at the Moroso instructions, they tell you to put it in the wrong way. Let me show you something. Let's see if I can get. Let me get a pen and a whiteboard. So, hang on for a moment. That was a struggle. Can't weigh more than 15 pounds. All this time just to get this up. Now I have to admit, it's a bit of a mystery why. They may have changed their instructions because somebody might have told them. It's a mystery as to why Moroso ever instructed you to do it this way. Here's your collector, right? And they say, put it in like this. It goes off to the exhaust. So your exhaust is going over the end like that. No, don't do it that way. Put it in. Can you see that? Yeah. Put it in so that it's like this. That there will get at least twice the suction of that, at least. Usually this gives barely any suction on some exhaust. It has to have a huge volume going by it to work. This one here will give you very good results with very little effort. So if you can use a vacuum pan setup exhaust driven one, that's the way to do it, right? You have been told. Now, what's the time? It's getting on for my breakfast time. Yes, folks, I haven't had breakfast yet. That's one of the problems with being a diabetic. If your sugar's high, you don't eat. And it was, so I haven't. Oh, let's get that out of the way. Okay. I are back. Now then, let me see what the time is. It's 8:49. Let's see if we've got any interesting stuff here. We've had a pretty good xylene. Oh, Scott 74 says xylene without octane. Yes, but at this moment in time, we're looking for combustion efficiency, and methanol is not the easiest stuff to ignite. One of the things is it works best with a lot of fuel, and a lot of fuel usually means a lot of large droplets and a lot of ignition timing, right? One of the best ways to get alcohol to work good is huge amounts of fuel pressure and very finely atomizing nozzles. Xylene. Look, don't worry about spelling. Let me tell you, for a guy that made a lot of his income, a good proportion of his income from writing, I am probably amongst the world's worst spellers. Don't worry about it, right? It's not you that's gone off the rails. It's the English language never was on the rails. I mean, look, think how many ways you can spell different words. Like, here's one, which is right. Antelope for the animal, and Penelope for the girl's name? Or is it antelope for the animal and Penelope for the girl? You can't both be right. They're almost spelt the same. I can claim something here that most people can't do. I can spell door 4 different ways. They all look right to me. Going to be building a normally aspirated 383 hydraulic roller small block Chevy Street. What coatings on what parts and what oil will be compatible? Well, now that's a good question here. This is LJ Power Sports 3675. Is it? That's a good question. Thanks for being a member. I appreciate that. In fact, I am absolutely loving seeing all these members here. You know, you guys are asking really good questions. Not that the other guys aren't, but these are. Now, building. Well, first off, I would look at the coated pistons that come pre-coated from Icon. They're already coated with a very good coating, right? Now, the Marley pistons, they're very nice pistons. The geometry is very good. It's coated with a good coating, probably not as good as the Icon one, but they come complete with very good rings, and that's a plus there. If I'm on a budget, I definitely look at the Marley rings, right? They're 1.2, 1.2, and 3 mil ring pack is very good. And for the piston crown, there's a bunch of them, right? If I were you, I would go into Google and Google the nearest piston coating company to you, because they're all over the place. Now, I use Calico Coatings, which is that way, Morrisville, about not Morrisville, Denver, about 40 miles. Denver, North Carolina, not Denver, Colorado. And another one is Line to Line, and they're over there about 300 miles, maybe 400. They're up in, got it. It's up in the motor industry area, right? But I can't figure out quite where. If you Google line 2 line coatings, you'll come up with their address. They have got a coating which goes on the top of a piston, which makes your piston bulletproof in a top fuel car. Just about. Top fuel guys who aren't using these are losing pistons. They need not lose. The fastest guy in Australia, top fuel guy, actually at the time I did a lecture down at his shop, he was the fastest top fuel guy in the world. And he worked out that when I showed him this line-to-line coating, he worked out that it would save him somewhere in the region of about $80,000 a year in pistons. Now, in Australia, most of the racing is done on the East Coast. So traveling wasn't a big deal for him compared with what it would be in America, where it's all over the place. I mean, they would race in Perth, I think. So once a year, they'd trek all the way across country, 3,000 miles there and back, 3,000 miles there, 3,000 miles back, but the rest of the time. And that coating, I was shown a piston that had done about 16 competitive passes, and the piston crown looked like it just been down to the local supermarket and back, line to line. Are we still talking about the silver head challenge tonight? Do you mean cylinder head? You're doing this with a microphone, aren't you? Right? Mike Spurley. I thought we'd done that, Mike. But don't worry. You should have received a email today. Check your email. If you haven't received anything, just email me tomorrow, right? Cylinder, yeah. Floyd Carriage. Floyd's car, I saw flat tops to 13-1. Yeah, flat tops are always a good bet. Very rarely do you get more power from any other shape of piston, unless it's a special occasion, like you've got to have something a little bit different for, say, a Hemi or something like that. So it's a surefire bet. It is going to work. It may not be the ultimate, but it will not work, right? I always go for a flat top if I'm building an engine. I want a straightforward, good build flat top piston. Floyd's Garage. YW. Not sure what that is. Oh, yeah. Yeah. Shane. Yes. You've got to have baffles in the oil covers, or you're going to have a really messy deal there. Yeah. Oh, now I'm still not up to speed on this, but I've tried coated bearings, calico coating, and not coated bearings, right? And I really couldn't see, I wasn't having any bearing problem, right? I was using a good synthetic oil, and I couldn't tell much difference. But here's the thing, a ex-NASCAR engine builder friend of mine, he accidentally started a motor and ran it down the quarter mile with no oil in it. All it had was the build oil. Then he panicked, realizing that he hadn't put the oil in. When they tore that engine down, the coating was just about gone through, but it didn't touch the actual bearings, right? So he said, save the crank and everything. So as a safety measure, you can bet that it works. Anyway, I'm going to look at one more question here, and then, folks, I've got to start to wrap it up. Robert, W5U4B. Wonder what that stands for. Is direct port water injection on a LS3 with stock intake manifold a good idea? It is a 416 and the compression ratio is 11:1, and we'll be running 20 pounds of boost. Now, hoping to run on 91. If you put water injection into the, and it's good to have it in each port so that you have an even flow, because 20 pounds of boost on an 11:1 compression ratio, any shortage of water, that cylinder is history, right? And make sure you put plenty of water. Start off with too much. What's too much? When you see steam coming out of the exhaust, it's too much. And back it off until you see that it's a clean burn, no overheating the electrodes, nothing. And check your performance with a draggy, one of those things. Good deal. You'll be able to get an idea of your horsepower and how well it's going. Right. Okay, guys, look, thanks for all of these questions here. It's been a great night talking to you. Shame Greg couldn't stop a bit longer, but I'm going to have to sign off now because it's late. I was up early and I was up late last night, so I need to get some sleep. But check this out again, 7 o'clock Friday. Think of those questions. And you members here, if you still have any questions, email me. When you make it the title for it, put it in big, capital, bold letters, cylinder head competition question. Because I need to give you guys priority, right? Right now, you're the most important people, other than my part suppliers. So I need to look after you guys first. So email me with your responses there. With that, I'm going to say good night, and I will see you guys on Friday. Thank you for watching.